In this question, from the November 2007 paper on P&C, we have a group of 12 people, okay, that consists of 6 married couple. First, this question talks about if the group stands in a line, find the total number of possible order. Okay, so for A, it's quite straightforward. The number of ways will just be going to be, there are 12 people that's going to be standing in a straight line, so to rearrange these 12 people, it will just be 12 factorial. Okay, part A, part 2, the man must stand next to the wife, so there will be 12 slots, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, okay? Each man must stand next to the wife. Man, wife, man, wife, man, wife. You get what I mean? So in total, there are going to be 6 units because I grouped the man and woman, the man and the wife to be together. So that would be 6 factorial ways to rearrange all these 6 units of couple. Okay, now within each of them, they can switch place. So for example, couple 1, I switch place, 2 factorial. Couple 2, I switch place, 2 factorial. Couple 3, I switch place, 2 factorial. Couple 4, I switch place, 2 factorial. And you get what I mean? I can switch place for all of them. That means I will have 1, 2, 3, 4, 5 times 2 factorial, 6 times. Okay, and you are going to get your answer. All right. Now for B, it's going to be a different kind of question because now the group stands in a circle. Just a quick recap. If I am going to sit n people in a group of circle, the number of ways is going to be called n minus 1 factorial. So B part 1, the total number of possible arrangement to sit 12 people in a circle is going to be 12 minus 1 factorial, and you are going to get your answer over here. Okay, part 2 is pretty tricky. The total the number of different possibilities if the men and women alternate. Okay, so for this kind of question, we use the slotting method. Okay, if you are not sure about all these terms that I'm using, it's best you go and recap your notes. Okay, so now let's say I put all the men inside first on this table. 3, 4, 5, 6. There are going to be 6 men. Each of the men beside them is an empty slot because the men and women must alternate. So let's settle the men first. Number of ways for men is going to be, there are 6 men in a circle, 6 minus 1 factorial. Okay, so that's for the men. Now for the women, which I'm going to put in red, okay, there are 6 women left. There are 6 possibilities to fill in the first seat. There are 5 possibilities to fill in the second seat. There are 4 possibilities to fill in the third seat. There are 3 possibilities to fill in the 4th seat, so on and so forth. And then you realize 6 times 5 times 4 times 3 times 2 times 1, that is going to be 6 factorial, and that's how you are going to get the answer for B part 2. Okay, so first we permute the men in the circle first, then we use the slotting method for the second part. For part 3, how many different ways are there if each man must stand next to his wife and the man and the wife can alternate? Okay, so again, let me draw this table. This man 1 must sit beside his wife. Okay, so there will be man 2, wife 2, man 3, wife 3, man 4, wife 4, man 5, wife 5, and man 6, wife 6. Total, there's going to be 1, 2, 3, 4, 5, 6 groups of people. So the number of ways to arrange these 6 group of people is going to be called 6 minus 1 factorial because they are one group and they are in a circle. Okay, now if the man doesn't sit here, if we change the order, the women sit here, the men sit here, this guy must change. Everybody must change their seat because the question did say that the men and the women must alternate. So woman 2 must change place with man 2. Woman 3 must change place with man 3. Woman 4 must change place with man 4. So on and so forth. There are only one other way because the man and the woman must alternate. This is the only other way. Woman 5, man 5, woman 6, man 6. Okay, the only other way that can happen. So I multiply by 2 because the first way is in blue. If the man sits on the left and the women on the right, that's the first way. And if the woman and man for the first group switch place, everybody must switch place already. Okay, so that is the only other possibility, and you are going to get your answer for B part 2. And this is how you do a question that involves line as well as circle.